I would like to move on to our COVID-19 analysis. And this is still, I want to caution that this is still preliminary. This work is still ongoing. We've been working every day in terms of crunching the numbers with this data. But I'm very excited to share these preliminary results, especially in this forum, because of the implications that it can have in Japan, but also in countries such as India and Philippines. So let's talk about and Japan is a very unique study because, as many of you know, there have not been any compulsory measures. There were no mandatory measures that were taken in Japan. As you can see here, there were different events. It was in January, right? And then the schools, and so there were various incidents that happened, and schools were closed around the 1st of March. The Olympics were postponed, and the state of emergency was issued in the first week of April. Right? So we can see the number of cases that were there of COVID-19 increasing over a period of time, but Japan never really did mandatory lockdowns like the US, India, and various European countries and so on, right? So the small count of patients and deaths despite the proximity to China and all of these other locations. So it's a very unique setting. So the question is, can we really understand what's going on, right? How people are maybe self-policing themselves, how they're constraining their mobility, so that we can actually see what are the type of trends in terms of city movements and how that relates to COVID-19 infections. So this is a quick graphic of the reductions in terms of the mobility patterns. So this first one here, right, almost downtown Tokyo on January 20th, which is pretty much a usual day here on a Monday, 12 in the afternoon, right? And here you can see by March 30th, although there were no lockdowns, you can see about 50% reduction in terms of this mobility patterns. And by second week of April, about 80% reductions in all the busy areas, busy metro stops in Tokyo, right? So our collaboration with Yahoo Japan gives us this very valuable data of people mobility movements. And it tells us how many visits are there for different points of interest, POIs. And we do a lot of data crunching to understand how this big data can inform how people's contacts have changed over space and time. And if so, how did this affect the transmissibility of COVID-19? As we discussed before, those three classes of problems, we can then do evaluation, we can do prediction, but we can also do what-if scenarios. What happens if there were other kinds of lockdowns, or if there were more stricter control measures? Would that really have been beneficial? So we can do all of those different what-if analysis to see what the impacts would be. So this is a slide which shows the decrease in social contacts. Here is the contact index. Contact index is a relative measure as to how much percentage of contacts were actually reduced as compared to a typical day during the same time period, right? And you can see that weekends, less number of contacts even during regular days. But once you see the COVID situation has happened, there are almost about 60% decrease even before the state of emergency was actually issued. And you can see that it actually reduced to almost 80% just after the state of emergency was actually issued. Some key things to know. First, well, across all the 23 districts that are there in Tokyo, right? I mean, there is a disproportionate decrease in terms of these contacts, right? So some have lesser, almost no reduction over time. Some actually, and over time, you can see that all of them have a reduction, but they actually vary. Some of them have more reductions, some of them have lesser reductions. So you can see that they're reduced by almost 60 to 70%. The second key insight we want to kind of show you here is the income inequalities that are there in terms of how mobility restrictions impact people. You can see here that the x-axis is the income. Here, when you're moving away from the origin, it's higher, richer people. Richer people have higher reductions in terms of these contacts, whereas poorer people do not have the same luxury because of the kind of jobs they might be doing, or they have to maintain their job, they may have to actually travel and so on, right? So the lower income people have lesser flexibility in terms of decreasing the kind of contacts. Here you can see this strong correlation between mobility and the R of T, which is the index which measures the spread of this disease, right? And what you can see here is this reduces quite a bit as a function of time, right? And so you can see that the RT, when the mobility is reducing, you can see that the RT value keeps changing. But beyond a certain point, right, the contact index doesn't decrease significantly. And thereby the RT values is also not changing significantly. So after April 1st, although it has reduced from 60 to 80% in terms of the contacts, the RT values are not significantly impacted, which means it doesn't really have a big bearing in terms of the number of infections because the contacts have already reduced, right? So the question is, I mean, this is a thing which most countries don't know right now, right? Which is what is the right level of restrictions we need to impose without causing severe economic damage to the economy, right? And so if we were to think about this, maybe we don't need these severe mobility restrictions. There is a sweet spot in terms of how much mobility is good so that we can balance between reducing these infections due to COVID-19 and also keep some of the economy functioning, right? So that we maintain that economic activity as needed. That can happen. So our sweet spot here is the 0.65 in terms of the social contact reductions. And that can happen by different kinds of POIs, right? By keeping open different kinds of activity patterns. Here is one graphic which shows the kinds of activities you want to keep open. So the different kinds of businesses in the locations, shopping, parks, stations, and airport. So you can see that this level of reduction in terms of these visits would achieve this reduction of 0.65 level of contacts, right? And this is a key insight and can provide guidance in terms of not only for Tokyo and other cities in Japan, but also outside in terms of how mobility restrictions can help, right? Reduction of the disease, but maybe we don't want to overdo it so that we actually cause severe damages to the economy, because once you shut down the economy, bringing it back to life completely is very, very hard. Okay, so that's our paper, and the full paper is available in this archive link. Happy to share with you after this. Also happy to answer more questions. There's some very interesting questions we are exploring right now, right? So based upon this, we are looking at one, income inequality and the type of jobs which are actually impacted because we have the data for small businesses versus big establishments. So we want to see if there is more impact on small businesses versus large businesses, what the impacts are, how much time it would take for it to recover, and so on. And how will this, we also want to understand, which a lot of countries are grappling with right now, how will this mobility patterns and proxies the economy change after we lift this state of emergency? And similarly, how will this transmissibility rate, RT, change as we are kind of lifting some of these restrictions? So again, we don't have to just see the current data. We can do different what-if analysis to understand this particular issue. And we have a lot of very good US data from SafeGraph, another collaborator of ours. And what we are doing is we are doing analysis to see how different openings. I live in Ohio right now, and Ohio it already opened last week. And we can see how different opening of these businesses is going to impact the infections, but also is going to impact the economy at the local and the state level. And do we observe any kind of inequality similar to Japan? Actually, it might be even worse in the US. We see a lot of income inequality. We see urban-rural inequalities where rural areas have actually suffered more as compared to urban areas. And then how can we apply the insights which are obtained from Japan and US so that we can translate some of these findings to countries which are data poor, right? Like, for example, India, where there's not a very high quality data. There are companies like, for example, Quebec, which have some amount of cell phone data. And we have partners in TISS who are social scientists who do survey data collection. And we want to see, because a lot of migrants have moved to various points, we want to see how many of them do come back, how many of them may not come back because they don't have a job, and what are the impacts of the economy in countries like India, where perfect data might not be available. So that's another ongoing research that we are pursuing right now. And we are also working, I have a PhD student who is looking at the integration of mobility modeling with this SEIR model, the infectious disease model, to understand how different kinds of controls, right? Like for example, quarantining or closing certain transit stops, how does that impact the effect of the transmission of these diseases? And we applied this to New York City. And here what you can see is this is our predicted number of infections over time from mid-February, early February till April. And this is the data, right? This and the dots are the data, and this is from our Trans-SEIR model. And you can see that there's a reasonably what the actual data actually shows us. And what we see, the key insight from this is these are the different regions in New York. And you can actually see that based upon these different control measures, you can see that the travel, restricting certain kinds of travel would restrict the, reduce the number of latent infections that are there by almost about 29%, and the corresponding changes in the R0 values in terms of the spread. And you can see, depending upon how much resources you spend, you actually can save almost 700,000 people from infections just by spending about $20 to $30 million in New York City, right? So there are a lot of different what-if analysis we can actually do with this model. I don't want to present all the details of the model, but I'm happy to share the impacts and how one could actually use this. So let's take a pause for 1 minute here. If there are any pressing questions, I'm actually happy to answer 1 or 2 questions here. Taka, have you received any questions so far?
Yes, so I have one question from Ahmad. It says, thanks, sir. My question is related to the resilience. As what you mentioned in terms of resilience, is there any information that relates with how we can measure resilience, and what factors significantly influence the resilience? How can we understand those questions?
Right, right. Okay, so let me answer that question in the context of disasters, because the answer will vary depending upon the kind of shock we are kind of dealing with, right? So in the context of disasters, how do we measure resilience? So, I mean, the definition of resilience is whether a particular system can, 1, absorb the shock, and 2, how fast it can bounce back. And that bouncing back can be measured in different ways, right? That's where the metrics come in. And the metrics that we usually look at are different things. 1, we look at whether people are coming back, because really for a community to thrive, people have to come back. It's not fixing just the roads, it's not fixing the power lines, but it's people, are they coming back? And are they able to find employment opportunities? Are they able to have the quality of life that we expect them to have, right? So that is where this mobility data is very useful. So we look at the returning behavior of people over time, how much time it takes, and which areas are they settling down, and what type of job opportunities do they actually get. So we use those kind of measures in terms of people's returning behavior to see if the city is actually resilient. And then on top of it, we also look at whether the power has come back, whether the roads are functioning, whether schools have opened. So the infrastructure related decisions are, we have very specific metrics like travel times, right? Number of houses which have power, when do they have power, and so on. So we can kind of measure those things. That's the first answer to the first part. What's the second part, Taco?
So the second part was, so what factors significantly influence such resilience metrics? Right.
So there, again, in the context of disasters, the factors that influence are, 1, the big factor is the connections that are there within the community, what we call social bonds or social ties that are there within the community. I will talk about that a little bit as I move along, so maybe we can go into some of those details later on. 1 is the social connections, 2 is the financial capital that is actually there. And I'll talk about a few other factors as we go along. Okay.
We have 2 further questions. Maybe Peter first and followed by Dina.
Okay.
Yes, thanks very much for a very interesting presentation. I just wondered if you could explain a little bit more about the social contact index, about how that is measured. And then in terms of your finding about the sweet spot, in terms of the distancing reduction or increase versus the RT, I'm just wondering how applicable that might be to other countries and cities, given the fact that Japan does have sort of various special characteristics.
Yes, yes. Okay, so the social contact index, right, so is actually measured based upon the mobility locations of different people. So if two individuals are coming within a certain proximity to one another, based upon the boxes that we actually draw, because there's some error in the GPS and so on. So we take that into account. And when we see that two people are co-located in space at any given time, right, that means there is a contact which actually happens. So that's a measure of contact. And we measure how many of those contacts happen at any given time. So this index is a relative notion. So we have those contacts for a typical day, and we have those contacts post-COVID, like on every day, every hour, and so on. And then we are measuring those relative to the number of contacts that are there in a given region to what they would have been on any typical day that is there previously. So that's the measure of index that we are seeing. So essentially, it's a number of people who are, if you were to build a network, this contact network, it's how many people are co-located with one another at any given time, right? So that's the metric that is there. About the RT values, it's true that, I mean, certainly because of the kind of cultural behavior that might be there, or the norms which are there in the society, the RT value is what we actually see is specific to Japan. But the RT is closely related to the contacts. So the contact index. So if you were to be able to measure the similar contact index in different country, you can kind of also impute what that RT value is.
Okay, thank you.
There was one more question.
Hello, Professor. Good morning. My question about Y Mobile. So you collected data from Y Mobile. I guess only the contracts, the phones which link to contract with Y Mobile. So my question is how to select this operator in a country, because in many countries I know that some mobile network, they are like budget, so they are specifically attractive for low-income people, and some networks for higher-income people. So I'm not sure how is it Y Mobile in Japan. Is it like many people covered by Y Mobile? How to select? So if I want to do research in a country, so how to select the operator?
That's a very good question. So this Yahoo Japan data, right? What we see is it's an app which is installed by different socio-demographic groups within Japan, right? So it has a very good coverage in terms of, one, the areas, of course, is more represented within Tokyo, but in terms of the socio-demographics, it's pretty nicely, it has a very good coverage across all different types of people in Japan. Related to your question, in other countries, it is true, like for example, in Africa, in Kenya and Rwanda and so on, yeah, there is certain Wi-Fi plans and certain carriers are primarily used by high-income people, and certain other cell phone plans are used by low-income people and so on. So typically when we do this research, we are not working with a cell phone company. We are working with a vendor who kind of collects the data from all of this sample of all of these different cell phone companies, and they're actually giving us that cumulative data, right? So when we actually sometimes say we don't even know who the cell phone provider is for that, we just have a good population data for different groups from that particular country, right? So it's not selected based upon the carrier. In those countries, it's a cumulative of all of these different groups. Okay.